Okay, good afternoon all. So today we are going to start the destructive testing methods. Now, already as we have discussed the what is the difference between the destructive testing methods and non-destructive testing methods. Destructive testing methods generally at the end of this test, it will result in some damage to the component, or it may result in the reduced service life of the component. But in the non-destructive testing method, it does not damages or it does not reduces the service life of the component. And the second big difference between the destructive testing and non-destructive testing method is that in the destructive testing method, we will get or it will these destructive testing methods are helpful to determine certain properties of the material. For example, you can determine its tensile strength, its hardness, its compression strength. Then you can determine its ductility, malleability. Like these kind of properties can be determined by with the help of the destructive testing methods. And in non-destructive testing methods, these are very helpful to detect whether any kind of defect is present in that component, defect or flaw in that component, that we are going to determine with the help of that non-destructive testing methods. Now there are different types of the destructive testing methods and non-destructive testing methods. In the destructive testing methods, as far as our syllabus is concerned, we are having 5 destructive testing methods: tensile testing, then hardness testing, impact testing, fatigue testing, and creep testing method. Okay, on these 5 tests, we are going to study in respect to the specimen preparation, then test procedure, then what are the results we are getting in it, and which kind of the results or output are there, that we are going to discuss in brief in this destructive testing methods in all 5 types. And in the non-destructive testing method also, uh, already we have discussed that part. In the non-destructive testing, we are going to see the different types, like visual inspection will be there, then magnetic particle testing, ed current testing, liquid penetrant testing, radiography, and ultrasonic inspection. These we are going to discuss in the brief. Now, in today's lecture, we will start with this tensile testing. Now, for this tensile testing, first, in tensile testing method, you have to first explain the preparation of the specimen, and after that, this is the specimen preparation diagrams, which kind of the specimen you have to prepare. And then after this is the schematic illustration, or you can say that the arrangement, which instruments we are going to use there. This is a general diagram for a universal testing machine or a tensile testing machine. And then after this, we will discuss the first part will be specimen preparation, then how the actual test is conducted, that we are going to discuss with the help of this diagram. And then what will be the outputs obtained. It may be a load extension curve or stress strain diagram. Then different types of the stress strain diagrams for different kinds of the materials. For ductile material, different stress strain diagram will be there. And for brittle material, different stress strain diagram will be there. And for plastic materials, different diagram will be there, that we are going to discuss in brief. And after this, the very important point, that is which properties can be determined with the help of this tensile testing. Okay, lots of properties can be determined. This is the list. These properties you can determine at the end of this tensile test, conducting the tensile test on particular material. Okay, now we will discuss one by one. First we will start with the specimen preparation. Now here, okay, first I will explain the procedure, and after that we will go to the specimen preparation. Now, this is the universal testing machine. These We are having this universal testing machine in our lab also, and we are going to conduct the practicals on that. And this will be the arrangement. Okay, this is the general arrangement or general diagram. uh, just you have to understand the concept how this test is conducted. Now there will be an arrangement. You can say that there will be two supports. These are the supports, and in this, with the help of these supports, you have to fix the specimen. Okay, this is your actual specimen, which diagram is shown in this first slide. Different kinds of the specimen may be there. This is your actual specimen. Okay, this is this prepared specimen. Now here, this specimen may be having different cross sections. It may be circular cross section, it may have circular cross section, or it may have square cross section, or it may have a rectangular cross section. Okay, initially this specimen is prepared, and you can use either circular cross section, square cross section, or rectangular cross section. Okay, then after, now while preparing this specimen, you have to take care that there should not be any sharp edges. You have to avoid the sharp edges. If any kind of sharp edges are present in that specimen, then it may result in the sudden failure. Due to that sharp edges, some stresses will get created there, and it may result in the sudden failure of that material or that test specimen. And to avoid that, you have to take proper care, and there should not be any sharp edges in that whichever specimen you are preparing. You have to avoid the sharp edges, because it will result in the sudden failure of the material under the tensile loading. Okay, then this is your specimen, and at the center, this is the gauge length. Okay, you have to, this gauge length, whichever gauge length is marked here, gauge length, or it is also termed as the original gauge length. Now, actual tensile, what is this gauge length? Actual tensile test, or whichever readings are taken, that are taken by considering this much length only. We are not considering the full length, overall length of the component or specimen. We are just considering this marked gauge length. You have to mark the gauge length. It will be denoted by L0, and this is the diameter, that is the D0. Only this much part or these much dimensions we are going to consider. Okay, while taking the readings, we are going to consider whichever changes are occurring in the length and diameter. We are considering only this portion for taking the readings. We are not considering the overall length of this specimen or overall diameter of that specimen. Just we are considering this marked portion, and this will be termed as the gauge length, and this is the corresponding diameter. Okay, now while preparing this specimen here, these ends, these are the ends here. Okay, these ends of the specimen, you can clearly identify here. This is the, you can say that this is the shouldered end. Okay, shouldered end. End may be of different types. Whichever specimen is there, you can use three different types of the ends. You can prepare the ends with, it may be a shouldered end. This is just the end. Okay, this is the shouldered end. Whichever end you are able to see here in this diagram, this is the shoulder end. You can use threaded end also. Okay, this is your gauge length. From this point, gauge length will start. This is the threaded end, or there may be a pin end. Okay, there may be a pin end. Depending on the shape and size of the specimen under test, you can either go for the shouldered end and threaded end or pin end. Generally the shouldered end is used. Okay, this is very important part for preparing the specimen. You have to choose any one end, shoulder, threaded, or pin end. And after that, you have to take that prepared specimen, and you have to fix that specimen in these two heads. In some books they have mentioned the anvils, or you can say that in between these supports you have to fix the specimen. And now, with the help of the arrangement, you have to apply the tensile load. Okay, you have to apply the tensile load on this specimen. Now gradually you have to increase the load. Okay, suppose you have taken, gradually you have to increase the load. Gradually we are going to increase the load, and for corresponding load, suppose first you have taken x. Okay, load as x, then corresponding, you have to measure whichever changes in the length or changes in the diameters are there, that you have to measure. Then in the second point, you have to again increase the load. then corresponding changes in the length and diameter you have to measure. Now this procedure you have to means you have to continue with this procedure. Gradually you have to increase the load, and you have to take the readings related to the changes in the dimension, that is change in the length and change in the diameter. Initially you have already initially you have taken the reading of, that is the initial length, you can say that the original gauge length and its corresponding diameter. Then at each step you have to increase the load, and for corresponding load you have to measure the length and diameter of that specimen. Okay, and depending on the load, then changes in the length and the diameter, you have to plot a curve that you will obtain this kind of the curve, that is the, you have to plot the load on y-axis, and you change in the length that will be termed as the extension on the x-axis. This type of curve will be obtained, and this curve will be termed as load extension curve. Now gradually increase of the load until that specimen breaks. Okay, till that you have to gradually increase the load, and for each increase in the load step you have to measure the corresponding change in the length and change in the diameter, and you have to continue this procedure until that specimen breaks. Okay, and when that specimen breaks you have to plot a curve by taking load and change in the length, or you can say that the extension. For corresponding load the corresponding extension readings will be taken and a curve is plotted, and this type of curve will be obtained, and this curve is termed as the load extension curve. Now here, this is the load extension curve. Now this 3 and 4 point, these are the end points. At this point 4 the corresponding specimen breaks. Okay, it get breaked. Now I will explain it again. This is your initial specimen. Okay, initial specimen without applying any load, and as you are increasing the load, here we are gradually increasing the load. As load is increasing, you can see clearly that uh, here the length will also increase. Okay, whenever you are applying a tensile load, as load is gradually increasing, the length of that specimen also increases, and its diameter decreases. Okay, its diameter decreases, and this process will continue till its breakage. And here, before the breakage, you can see here the necking starts here. This is the point where necking start. Necking, this is the shape where neck is formed. Okay, before the breakage, this is a stage where neck, here diameter reduction in the diameter is at a very faster rate, and before the actual breakage some neck will be formed. This kind of shape will be formed here, and that component will get breaked in the two pieces at the end. Okay, before the breakage, very diameter will be very small in nature. This process will be termed as the necking process, and it is indicated here. After this point you can say that this is the neck formation process. This is the load extension diagram. This is the neck formation process, and when diameter becomes very thinner at the end, this component will get broken into two pieces. Okay, and for each stage of application of the load, you have to, for that application of the load, corresponding change in the length and change in the diameter readings are taken and that are plotted, and this kind of curve will be obtained. This curve will be termed as the load extension curve, and this same load extension curve, this curve can be transformed to this load instead of this load. As load, it will result in this stress, and this extension change in the length, it will give you some strain in that component. This load extension curve can be transformed to the stress and strain curve. Okay, this is the stress strain curve. Here, two types of the stress strain curves are there. Just simply, I have transformed this load extension curve initially from that universal tensile testing, or in the tensile testing you are getting the load extension curve, and that load extension curve is transformed to the stress strain curve. Okay, the stress strain curve will be obtained and it will be like this, and different points will be plotted there. This is the stress strain curve. Stress strain curve, this is the true stress strain curve, and this is the engineering stress strain curve. Okay, now there is little difference. Now here we are getting two types of the stress strain curves, that is true stress strain curve and engineering stress strain curve. And what is the difference between true stress strain curve and engineering stress strain curve? Now, whenever you are calculating for a particular stress, whenever you are considering the exact change in the whichever reduction or whichever change in the dimension is there at that particular instant. Okay, I will tell you with the example. Suppose you have applied 10 kg of load initially and change in length is 1 millimeter. Okay, then for next you have increased the load by 10 kg, the net load will become 20 kg, and net change in length is suppose 3 millimeter. But the increased load is 10 kg in the second step and change in the length is 2 millimeter. Okay, for that particularly increased 10 kg, 2 millimeter change in length is occurring. Okay, then when you consider the actual change in the length instead of considering the combined effect, okay, as we are increasing the load step by step, suppose from 10 kg, 10, 20, 30, 40, 50 kg, like this we are increasing the load, and suppose the change in the length is 1 millimeter, 3 millimeter, 5 millimeter, 7 millimeter, like this. So this is the combined effect, of the combined load. When you are getting the stress strain curve with this combined effect, that curve is termed as the engineering stress strain curve. And when for plotting the stress strain curve you are just considering the actual impact, means when you have you increased by 10 kg and corresponding change in the dimensions you are considering, then that curve will be termed as the true stress strain curve. Okay, so this is the difference between true stress strain curve and engineering stress strain curve. When combined effect of that load and combined change in the length is considered, that will be the engineering stress strain curve. And when you are considering the actual changes when you have applying the load step by step, and for that corresponding change in the dimensions you are considering, and you are plotting that stress strain curve, then that will be termed as the true stress strain curve. Okay, so this is the difference between the engineering stress strain curve and true stress strain curve. And whichever gap is there in that curve or difference is there, that is shown in this diagram. You can clearly see this diagram here. Okay, so this is the difference between true stress strain curve and engineering stress strain curve. Okay, now these points, certain points are there which you are able to see here, that is this PS, that is the proportional stress, then UKS, that is ultimate tensile strength, then this is BS, that is the breaking stress. These all points, or what is the meaning of this proportional stress, or sometimes there may be a proof stress, then elastic stress, then ultimate tensile stress, then breaking stress, yield stress. All these points I will explain with the help of the diagrams in the next slide. Okay, so in this way this tensile testing is conducted. First specimen will be prepared and that specimen is taken, then stepwise you have to apply the load, and for corresponding loads the change in the dimensions, that is the change in the length and diameter values are recorded, and at the end we have to plot a curve by taking the load on y-axis and the extension or change in the length on the x-axis, you will get a load extension curve, and with the help of this load extension curve you can transform that load extension curve to the stress strain curve. As you know that from this load, this you will get the stress values, and that from change in the length values you will get the strain values. Okay, so then two types of the stress strain curves will be obtained: engineering stress strain curve and true stress strain curve. There will be slight difference between these two and engineering stress strain curve. Okay, so in this way this tensile testing is conducted. Now here the evaluation of the properties is done here. Okay, I will explain the terms. What is the meaning of these are the curves? Different types of the curves will be obtained depending on the material. Now here some curves I have taken here. You can see that engineering stress strain curves showing the various stress values with elastic and plastic region in the first diagram. That is the diagram towards the left hand side, and right hand diagram, it is the engineering stress strain curve showing the yield point. Now different terminologies are there, uh, that I will explain one by one. Now here please try to understand this. This is very important. This is the value first. Okay, this is the PS, proportional stress. Here in this diagram, PS is the proportional stress. Then what is the meaning of the proportional stress? Up to this point, the stress is directly proportional to the strain. Okay, you can see that linearity is there, that is stress is directly proportional to the strain. Up to this value it will be termed as the proportional stress. In this EL, this is the elastic limit. Okay, up to this point or up to this much load, that particular material will show the elastic characteristics. Means when you remove the load it will come back to its initial stage or initial shape and size. This will be termed as the elastic limit, and this is the ultimate tensile strength. Okay, ultimate tensile strength, this is the maximum amount of the load that particular material can sustain. Okay, that will be termed as the ultimate tensile stress or ultimate tensile strength also. Means maximum amount of the stress that material can carry. Then this is the last here in the BS, this is the breaking stress or fracture stress, you can say that. Breaking stress or fracture stress, at that particular stress that material get breaked, or it will get means it will get separated into two parts. Okay, as we have seen in the that load extension diagram. Okay, at this point it will get breaked into two components. At point number 4, this is termed as the breaking stress or fracture stress also. Component will get breaked at this particular amount of stress, and ultimate tensile strength is the maximum amount of stress that component can sustain. Then we will move towards the next diagram here. Here some yield points are shown here. Okay, this point first and point second, this is the upper yield point and this is the lower yield point. Upper yield point and lower yield point. Then what is the meaning of the yield point? Only one terminology is there in this second diagram, that is what is the meaning of the yield point. Now for this particular yield point, when the stress, okay, you can see from this diagram here stress is not increasing. Okay, in this region 1 to 2 clearly you can see that stress is not increasing, but value of strain is increasing. Okay, at this particular value or that particular stress value, that will be termed as yield point. At that particular point stress remains almost constant, but strain value increases continuously. That point will be termed as the yield point. Okay, stress is not increasing, it is almost remaining constant, but the strain value in that component or material increasing continuously. That point will be termed as the yield point. You can observe this. Here, stress is not increasing, it is below this point only in this region, okay, 1 to 2. But strain is continuously increasing. So, this is termed as the yield point. And after this, we'll move towards the different types of the stress strain diagrams are obtained at the end of this tensile testing. Now, this question is very important. In instead of asking the actual tensile test or tensile testing procedure, lots of time they have asked the stress strain curve for ductile material, then stress strain curve for brittle material. Okay, now for ductile material, two types of the stress strain curves will be there. Okay, the stress strain curve for ductile material without yield point, okay, it is visible in the first diagram, and stress strain curve for a ductile material with yield point. Okay, what is the meaning of yield point? Already we have discussed that what is the meaning of the yield point. Then next two types of the stress strain curves are stress strain curve for the brittle material and stress strain curve for the polymeric materials. You can say that for plastic materials. These are the four kinds of the stress strain curve. Generally, these four kinds of the stress strain curve will be obtained for different. Either the material will be ductile or brittle or maybe polymeric. Depending on that, you will get the different types of the curves. Now, one by one, you have to, whenever any kind of curve is you are explaining, this terminology will be same. Okay, this proof stress, ultimate tensile strength, this breaking stress, it will remain same. Just you have to draw the diagram and you have to explain all the stress values. Okay, here you have to indicate the name, and in the explanation just you have to explain what is the meaning of this proof stress, what is the meaning of this ultimate tensile stress, then breaking stress. Then here yield point is there that you have to explain. Okay, kindly you have to draw this diagram. 'Kay, so I will explain it. This is the stress strain curve for ductile material without yield point. This is the stress strain curve for ductile material with yield point. Now the first stress is the proof stress. Okay, now here proof stress, it's a noise is there. One minute, 1 minute. Kindly draw the diagram. I will explain it. Please draw the diagram. Okay, in the first diagram, you can see here this is the curve for ductile material without yield point. This is the proof stress. Okay, there is some difference between the proportional stress and proof stress. The proportional stress is the stress up to that stress value. The stress is directly proportional to strain, and the proof stress at this particular above this point, or at that particular point, that material will show the permanent deformation. That particular stress will be termed as the proof stress. Okay, proof stress is the stress from above that stress, that particular material will show you the permanent deformation. That will be termed as the proof stress. Then ultimate tensile stress. Tensile stress is the stress value that material can bear, maximum amount of stress that material can take. That will be termed as ultimate tensile stress value. Then so, sorry for disturbance. Okay, some problem is there. Okay, I will explain it again. The ductile material is the first curve without yield point, and this is the curve with yield point. Already I have explained that what is the meaning of proportional stress, elastic stress, and proof stress. Above this value, or that particular above that value of this stress, the material will show you the permanent deformation. That will be termed as the proof stress. And this is the ultimate tensile stress, the maximum stress that material can carry without failing. That will be termed as ultimate tensile stress. And the material will get braked at a particular stress value. That will be termed as breaking stress or fracture stress. Okay, these terms you have to explain. You have to draw this diagram, and these terms you have to explain. Then in the ductile material, all these curves will be there. This is the first. Here first point will be there, proportional stress will be there. Then here this is the yield point. First point will be here, upper yield point, and this is the lower yield point. What is the meaning of the yield point? Ductile material, sometimes it will show you the yield point. Means here in this region you can clearly see that stress remains constant, but strain value increases. Okay, strain increases, but stress, corresponding stress value is constant. This will be termed as the yield point, and corresponding stress will be termed as the yield stress. Okay, then this here one point will be there. This is the ultimate tensile strength, ultimate tensile stress, maximum stress that material can carry without failure. And here at this point end, this is the breaking stress. or fracture stress. This is the stress at that particular stress value that material will get breaked or it will get failed, and that will be termed as the breaking stress or failure stress, you can say that, or fracture stress. In some books they have mentioned like fracture stress. So this is the stress strain curve for ductile material without yield point and ductile material with yield point. Okay, here they have not mentioned the names, I will mark you here. This is the first point here, this is proportional stress will be there, then this is the yield point, and this is the ultimate tensile stress UTS will be here, and this is the breaking stress or fracture stress. Okay, fourth point. Okay, this much terms will be there or this much stress values will be there in this curve. Then the next type of the stress strain curve, here you can clearly see that this is the stress strain curve for the brittle material. Okay, you can clearly see that it will, there will be one linear curve, and only two types of the stresses will be there here up to the linearity. Now, okay, up to the linearity mark, you can see that this is the proof stress will be there. Okay, this is the proof stress. Okay, proof stress up to this linear mark, proof stress will be there. Above that, permanent plastic deformation will be there, and after this only one stress, that is the breaking stress at this top point. Here breaking stress will be there. Okay, breaking stress will be there. Now here breaking stress and UTS, ultimate tensile stress, in this brittle material is approximately same. Okay, here up to the linearity mark, here you can say that this is the proof stress, and here you will get the UTS, that is ultimate tensile stress and breaking stress. Approximately for brittle materials, proof stress, sorry, ultimate tensile stress and the breaking stress is approximately same. Okay, approximately same. So this is only 2 points you have to mention here. This is the proof stress and this is the UTS. You can clearly say that approximately equal to the breaking stress or fracture stress. And the last type of the stress strain curve, this type of curve will be obtained for the polymeric material. This is the strain and this is the strain. This type of curve will be obtained. Okay, up to this proportional stress will be there. You can mark that. Now this is the breaking stress. This will be the breaking stress. Now here for each type of the curve you have to mention some examples. I will mention some examples for this last one. For polymeric material, you can say that different types of the polymers. Yeah, you can say that natural rubbers or synthetic rubbers are there, or different types of the polymeric compounds are there, that you can say that they will show you these types of diagrams. Natural rubber or synthetic rubber you can write here, or different kinds of the polymers. Then the brittle material, stress strain curve for the brittle material, this kind of curve will be obtained for gray cast iron, white cast iron. Then different kinds of the ceramic materials are there, or different kinds of the hardened steels are there. They will show you this kind of curve, stress strain curve for the brittle material. Then the stress strain curve for ductile material, first kind of curve will be obtained for copper, then nickel, copper and nickel alloys, then silver, gold and their alloys, silver, gold alloy, then aluminum, then lead. They will show you the ductile material curve, stress strain curve for ductile material without yield point. Repeat these examples: copper, nickel, then copper and nickel alloys, then silver, gold, okay, then lead, aluminum, platinum. They will show you this kind of the curve, first kind of the curve. And this ductile material, stress strain curve for a ductile material with yield point, this kind of curve will be obtained for low carbon steels, then low carbon low alloy steels. Then you can say the type of low carbon steel, particularly for example mild steels, will show you this kind of curve, that is the stress strain curve for ductile material with yield point. Okay, while explaining the stress strain curve, you have to draw the stress strain curve. You have to explain the terms involved in the stress strain curve, like proof stress, proportional stress, proof stress, ultimate tensile stress, breaking stress, and yield stress or yield point. And you have to write some examples. Okay, for each material, you have to write some examples. Okay, I will repeat some examples. For the first ductile material without yield point, you can write examples like copper, nickel, aluminium, gold, silver. And for stress strain curve with yield point, low carbon steels, in that mild steel you can write in low carbon low alloy steel. And for brittle material, gray cast iron, white cast iron, and different kinds of the hardened steels, these are examples for the stress strain curve. For all these materials, this stress strain curve will be obtained. Then for polymeric material, you can write the different kinds of the rubbers. It may be natural rubber or synthetic rubber. Okay, so these are the stress strain curves which are obtained at the end of tensile testing for different kinds of the materials. Then this is the end point for this particular tensile testing. With the help of this tensile testing, these properties can be determined. Okay, only I think from the name itself, you are thinking that this test is only helpful for determining the tensile strength. This is not the case. You will be able to determine the tensile strength. Along with that, you will be able to determine other different properties like proportional stress, elastic stress, ultimate tensile stress, breaking stress, yield stress. Okay, all these value you will get it from the curve only. Then next properties, you can able to determine the resilience of that material. Okay, resilience is nothing but total amount of energy absorbed by that particular material up to its elastic limit. Okay, up to its elastic limit. Then toughness, total amount of energy that material can absorb up to its, you can say that the breaking stress. Okay, or total amount of energy that material can absorb before failure, that will be termed as the toughness of that material. Then these kind of different properties you can able to determine. The ductility, malleability. Now ductility is the property that is the ability of a material to draw into a fine wire, that will be termed as the ductility. Then how to determine the ductility? By determining the percentage elongation. By determining the percentage of elongation, from that you will be able to determine the ductility. And from percentage reduction in area, you will be able to determine the malleability of that component. Okay, ductility and malleability. How to determine the ductility? How much you can do the elongation, means ability to get drawn into a fine wire, that is the elongation percentage. And ability to draw into a thin sheet, that you can say that percentage reduction in the area. Okay, in this way you can able to determine ductility and malleability. And then type of the fracture, depending on the type of the fracture, you will be able to determine different kinds of the defects or flaws present in that component. Easily you can determine that. And then stiffness is there. What is the stiffness is nothing but the resistance given by the material for elastic deformation, that will be termed as the stiffness. And then you will be able to determine the strain hardening coefficient. Some equations are there. With the help of that equations and with the help of the different stress values, you can determine this hardening coefficient also. Okay, then these kinds of different properties you can determine. Okay, these are the results or properties that can be determined with the help of the tensile testing. Okay, in this way we have completed this part, the tensile testing. In this tensile testing, we have started with the specimen preparation, then how to conduct this test, its test procedure. Then what are the results obtained, means different kinds of the load extension curves will be there. And from that load extension curves, we will get the a different stress strain curve. Then what is the meaning of true stress strain curve and engineering stress strain curve? What is the difference between these two curves? Then what kind of different kinds of the stress strain curves obtained for ductile materials, then brittle materials, and different polymeric materials, and which properties you can determine for a given component by conducting this tensile test. Okay, this is the list. These properties you can determine very easily. Okay, in this way we have completed this tensile testing part. If you are having any query, you can put that in the chat box. Otherwise, I will stop this session. Please mention that in the chat box. If you are having any query, please mention that in the chat box. Or if all points are clear, you can mention that in the chat box so that I will stop the session. Sachin is there. Sachin Chirsagar.
Yes, yes, sir.
Sachin Chirsagar is there.
Yes, sir.
You are not audible. Okay, you are there. Your voice is not audible. Okay. Mm, please provide me replies. If you are having any query, put that in the chat box. Samar Chauhan.
Yes, sir.
Okay, you have understood. Okay. Okay, we will stop here. If you are not having any query in this tensile testing, and in next lecture we will start the impact testing, fatigue testing, and that I will try to complete in the once lecture only. Okay, maximum 3 lectures I will take from here to complete the remaining tests. 3 lectures will be required. Okay. Okay, thank you for attending the sessions. You can continue with your remaining session.